All right, friends, here we go. Lesson 1-1. We're going to talk about sets. Can you use correct notation and perform operations relating to sets? So let's talk about, well, what is a set? A set is something that helps us visualize, explore, and analyze mathematical relationships. A set is defined as a collection of any objects. Okay? We name a set with a capital letter and the braces. These are braces. Remember, the square ones are brackets, and then we have parentheses, so don't get them all confused. Okay? Elements slash members are the objects within the sets. And set builder notation is how we describe a set. There are two ways we describe a set. We can either describe a set with set builder notation, or we can use a set element list. So the first example would be set builder notation, and we read this: set C is equal to all elements X such that X is a letter in the word peacock. That little line right there is read such that. Okay. Now, if we were going to list it as elements, it would be set C is equal to P-E-A-C-O-K. Now, the order isn't important. It could have been K-O-C-A-E-P. And also notice that each element is listed only once. There are two C's in the word peacock, but they're only listed once. So there's only one C listed.
Okay, so I'm going to lay some items out and I want you to tell me what kind of set this is. There's an external battery, some headphones, a charging cable and block. I'm sure you've guessed by now, and an iPad. So this is a set. This is the set of all items to use with my iPad. Now, I could either say set X, the set of all items that go with my iPad, or I could say set X, which contains a charger and charger block, an external battery, headphones, and an iPad. So there are two ways to name this set.
Okay, so there's a couple of symbols we need to talk about. This first symbol right here, it looks kind of like a uppercase E. That means is an element of. Okay, so if I were to say Miss Peacock is a member of the Bayshore faculty, you could put me in the set that contains all Bayshore faculties. So Miss Peacock would be an element of that set. This little zero with a slash through it or the empty brackets signifies an empty set or null set. Those are kind of interchangeable terms. So understand that empty set and null set are kind of interchangeable. Now, if we come down here and we look at equal, subsets, and proper sets, a lot of confusion comes between subsets and proper subsets. So I want to talk through these for a second, and then we'll look at example number 2. Equal sets are sets containing the exact same elements. Okay, so it would be 1, 3, 5, 7 for set A, 1, 3, 5, 7, 9 for set A, is exactly the same or equal to set C, which is X, such that X is between 0 and 10 and is odd. Well, those numbers are 1, 3, 5, 7, and 9. Now, subset means that every element in set B is also in set A. So let's look at what subset means. So subset B right here, if B is a subset of A, it means that every element in B is within A, which it is, and we write B is a subset of A, and A is a subset of C, because A, every element within A, is also in C. Now, the confusion comes in when we talk about proper subsets. This is really where I get a lot of kids being confused. So, a proper subset is where a set is a subset of another set, but is not equal. Once again, is not equal to set A. So, for example, B is a proper subset of set A because it is not equal, whereas A could not be a proper subset of set C because they are the equal number of elements. All right, adding a slash through any symbol indicates the relationship is not true. If we add a slash through an equals, it's not equals. Slash through element of, it's not an element of. Subset of slash is not a subset and not a proper subset. So let's look at example 2. Now, with these examples, I will always write my sets down. So let's look at the first one, number 1. Number 1 says that you have to read it properly, so bear with me. Set 1 is an element of A. Even though 1 is an element within set A, this says set 1 is within A. That is not true. That is false. Okay? 1 is an element within the set, not a set. B, it says A is not a proper subset of C. Remember, a proper subset is a subset. So is A a subset of C? 1, 3, 5, 7, 9. And C is where they're odd integers. Exactly the example we were talking about previously. But, like we said earlier, A is equal to C. Now, for it to be a proper subset, it is not supposed to be equal. So this is true that A is not a proper subset of C because they are equal. C, B is a proper subset of C. 3 and 7 are within B, and C is the odds between 0 and 10. So yes, true. All of the elements within B are in C and they are not equal. Last but not least, B is a subset of the empty set. You're not going to have a set within an empty set. So that is false. Okay, so let's look at how we can look at sets and set relationships a little bit easier. You've used these before, whether you know it or not, and these are called Venn diagrams. Venn diagrams allow us to illustrate relationships between sets. The universal set contains all the elements within the context of the problem. So if I were talking about Bayshore Christian School and the number of rhetoric, the set of rhetoric students and the set of logic students. The universal set would be all of the students at Bayshore Christian School from K to 12. Okay. Then we would have a set which would include the logic students and a set which would include the rhetoric students. Everybody outside those two circles would be within the universal set. Okay? All right, so that's the universal set. Now, equivalent sets are sets that have the exact same number of elements. They're not equal, but they have the same number of elements. For example, if we had, I know we don't, but if we had, 82 kids in the logic school and 82 kids in the rhetoric school, those would be equivalent sets because I could match up one rhetoric kid to one logic kid and everybody would have a partner. their equivalents. That's called a one-to-one correspondence. If you remember back to algebra, and we did the little ovals with the arrows that go from the domain to the range, as long as every member of the domain paired up with an element of the range, it was a one-to-one correspondence. Okay, and there was no, doubling up anywhere. Now over here, I have kind of shortcuts for integers, real numbers, whole numbers. Hopefully you got this a little bit in your algebra or pre-algebra. Integers, we just use the letter Z, real numbers R, and whole numbers W. You might see this within your homework a little bit, um, so just be aware that they're in there. All right, so let's move on down a little bit and let's look at this. We have some definitions here that you've probably already talked about. That's why I left them in a little bitty box here. But union means together. If we are going to do the union of A and B, it means all the elements in both sets. So as you can see right here, the union of A and B is coloring in both set A and set B. The intersection of set A and B is what overlaps. This little bit right in the middle, it's what overlaps, the intersection. And then the complement of A, if we are going to talk about the complement of A, if A is within the circle, the complement is everything that is outside the circle. Okay, so it's in the universal set, but not in the set A. Okay, all right, so let's use this information and let's go on to a better example, example 3. Now, before we start example 3, I want to show you just a couple of other definitions that you're going to see. You probably won't hear me say it too much, but you might read it or see it, so you need to be aware of it. A binary operation, bi means two, so binary operation is applied using two sets. A unary operation, uni meaning one, is applied to one set. And if we talk about disjoint sets, these are two sets that have nothing in common. They are disjoint, they don't overlap. Aliens and humans, we don't overlap, right? Hopefully we don't have any aliens who are humans, right? Okay, so let's look at example 3. Example 3 is asking us to use these sets right here and find union and intersection and the complement. All right, so we're going to draw Venn diagrams. I would like to draw Venn diagrams because I think it's fun to draw Venn diagrams. But I'm not. I'll do it in the next one. We'll save that. We'll save all the. We don't want to have all our fun at the same time. All right. So R. Watch how I do this. I'm going to write the set. R is 1, 2. Oh, come on with me. 3 and 4. Now we're unioning it or we're combining it with S. S is 1, 3, 5, and 7. So the union, all of it together, I'm going to put it in red, is 1, 2, 3, 4, 5, and 7. That is the union of R and S. Now if I wanted to do the intersection of R and S, so R is 1, 2, 3, and 4, and S is 1, 3, 5, and 7. Now we want to do the intersection. So it's what's in common. So let's look. Oh, I've got ones that are in common, and I have threes that are in common. So my intersection here is 1 and 3. That's my intersection of R and S. Last but not least, the complement of R. So in the universal set, if it's all single digit numbers, Okay, X is a single digit number. The universal set gives us 1, 2, 3, 4, 5, 6, 7, 8, and 9. So my universal set, oh, I don't want to use that. I want to use red, black. So my universal set is going to have the elements 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay? And then my R, set R, is going to have the numbers 1, 2, 3, and 4. Now it says, well, if R is 1, 2, 3, and 4, what's the complement of R? So everything that's in the universal set that is not in R. So 1 is an R, go away. 2 is an R, go away. 3 is an R, go away. 4 is an R, go away. So R prime, that's what that um, little apostrophe is. R prime is 5, 6, 7, 8, and 9. The set R prime is equal to the elements 5, 6, 7, 8, and 9. Okay? All right. So now we're going to draw a couple Venn diagrams to show the fun that is Venn diagrams and math. Now, I'll be honest, I'm not the neatest drawer. You know, Miss Baker's job is safe here. So let's look at this. Let's look at A. A says the complement of R intersected with S. So it's still the universal set with single digit natural numbers. Once again, this is 1, 2, 3, 4, 5, 6, 7, 8, and 9. I know those are looking like periods, but they're not. They're supposed to be commas. There we go. So it's our complement. Well, let's draw this universal set here. There's my universal set. Here is R, and here is S. I'll say R, I'll say S. So if I look at what's intersecting in R and S, it's 1 and 3. If I look at R, I also have 2 and 4. Now if I look over to my S, S contains 1, 3, 5, and 7. Now remember, within the universal set, I've got 1, 2, 3. Let's see, 1, 2, 3, 4, 5, 6. 6 is not in here anywhere, so it's kind of floating around out here. 7, 8 still floating around out here, and 9 is still floating around out here. So this says I want R prime, everything outside of R, intersected with S. So everything outside of R intersected with S. So everything outside of R, outside, is 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. Everything in S is 5 and 7. So this is everything outside of R. This is everything in S. Well, it's not everything, but it's the parts that's not intersected with R. Okay? So what that means is this 5 and 7, 5 and 7 are the intersection points. So that little blue area within the Venn diagram is R prime intersected with S. All right, looking at B, now we have to remember when we do these, it's kind of like an order of operations where we do what's inside the parentheses first. So the first thing it says is find the intersection of R and S. Well, we kind of already did that, right? We found the intersection of R and S, and that was just the little little circle in the middle, right? So here's our R, here's our S, This right here is the intersection of R and S. But what this problem says is the complement or everything besides the intersection of R and S. So friends, that's all this. So the blue area right here is the complement of R intersect S, the blue area. Okay. All right. So hopefully that wasn't too bad. Hopefully you've gotten it. We're going to go over a summary tomorrow. Please fill out your TRF forms. Hopefully you were filling those out as we went through this video. Hopefully you're filling out this informational worksheet that I gave you in class. And tomorrow during class, we're going to work on 1 through 33 odd. Remember to uh, step out of 1-1. You must take your exit ticket and successfully pass your exit